It's my real pleasure to introduce my friend and colleague, Jim Dobberstine. Jim and I met, I don't know how many years ago, when he was a student in my class. He got 2 master's degrees simultaneously here at UH Clear Lake, one in environmental science and one in environmental management. He started his life, well, he got his bachelor's degree from Concordia College, which I don't know where that is. Is that in Oregon? Is that Oregon? Yeah. He spends a lot of time on the West Coast. He started his professional life at the Houston Zoo, I think, did some zoo work, and then decided to move into the conservation field, and he worked at Galveston Bay Foundation. And then after he got his master's degrees, he moved on to Lee College, where he teaches environmental science, and he served for several years as the chair of the Department of Biology and engineering, and he had everything. So as that almost burned him out, he dumped that part of the job, and now he's happily teaching environmental science again. But he's the most energetic person that I've ever met. He serves on a number of boards, including the Galveston Bay Foundation, the monitoring and research subcommittee of the Galveston Bay Estuary Program. He's been the president for 12 years of the Texas Association of Environmental Professionals. He served as the president and board member of the Society of Environmental Toxicology South Central Regional, and that's just some of them. I mean, he's got so much stuff. He does permitting, evaluation work for the Army Corps of Engineers. He's just busy all the time. I don't know how he does it all. But I am privileged to be part of his research team. He's been studying living shorelines for a long time with his students at Lee College, and he's recently, on a last grant, included UH Clear Lake in it. So now we have a big conglomeration, and that's what he's going to talk about tonight. I will turn it over to you, Jim. See, I didn't tell you any bad stories about you. I could have, but I didn't. So there you go, Jim.
Well, thank you very much. And I have to acknowledge Cindy has been a huge influence on my second half of my career. I didn't go to graduate school until I had already been in the field practicing in aquatic biology for 15 years. And my experience at the University of Houston Clear Lake was it was a kind of a watershed moment in my career. And so Cindy's been a mentor to me, continues to partner with me we've partnered on actually a number of different projects over the years, and I'm really grateful for that. So thank you. Thank you all for having me. If I look this way, it's because I have 3 screens going on, which is a whole lot of technology for me. So I apologize for that. I'm going to try and stay focused. As you heard, we're going to be talking to you a little bit tonight about a project we have been working on for this particular project and data set is over the last about 5 years. And it looks at living shorelines. So I'm going to talk a little bit about what those are, why they're important, kind of their prevalence in Texas and in Galveston Bay, and then I'll talk a little bit about our specific project and our study. I want to acknowledge that one of our co-authors on this, Haley Laisha with the Galveston Bay Foundation, couldn't join us tonight, but she contributed significantly, not only to this presentation, but also to the project as a whole. And we are going to be continuing with this project over the next 2+ years under a new set of funding. And I'll talk a little bit more about that. I recently gave this presentation at the Restore America's Estuaries Conference back in December, but I only had 15 minutes to give it. So if you want a little entertainment, I understand this is being recorded tonight. You can go back and watch it again, but just watch it at 4 times speed. You'll see. Okay. So let's see if I can make that work. My guess is that everyone, or virtually everyone, in this virtual room has seen shorelines like this right here in Galveston Bay. That's where these pictures come from, where they are highly eroded. You have decay of uplands into open water, a loss entirely of any aquatic habitat along the shoreline that would typically be there. And unfortunately, this describes a significant portion of the Galveston Bay shoreline. And when you think about Galveston Bay being 600 square miles, there's a lot of potential shoreline. You can see the amount of erosion that is present there, and it can vary. But the drivers behind this are typically, it all comes down to erosion, and that erosion is primarily driven in Galveston Bay by wave fetch. So when, for instance, a lot of, Galveston Bay is very shallow on average, about 4 to 6 feet, depending on where you are. There are some areas, of course, that are a little bit deeper, but in those types of environments, tides are more affected by wind than they are the moon. And so that's part of why our tides are so typically low here. I'm sorry, not low, but they're so small. We don't have a lot of change from low tide to high tide, except when we have things like what happened yesterday. We had a front blow through, and when I drove over Armand Bayou on my way into campus, the water was, probably at least 3 feet higher than it was today. When the wind shifted, it blew all that water back out. Well, that movement creates a lot of wave energy within the bay proper. And those waves, when they interact with the shoreline, each wave acts like a little shovel, and it just scoops away a little bit of soil. And when you think about how many waves might hit a shoreline over the course of any given day, the amount of material that can be moved by that wave fetch can be very significant. Now, wind is not the only thing that can affect that. In many areas of Galveston Bay proper, the Houston Ship Channel has a big influence on that because of the large boats that come and go up and down the channel, which can affect fairly far inward in many of our bay-facing bayous, for instance. Boat wake, a lot of that can have an impact. Plus, we have ongoing subsidence, ground subsidence. And if you're not familiar with that term, it refers to the sinking of our soils, which are sedimentary, primarily from the withdrawal of groundwater, some oil and gas as well. That because we don't have traditional aquifers that are like caves, like the Edwards Aquifer, rather it's the interstitial spaces between individual soil particles, that soil can collapse, exposing soils that are not adapted to aquatic environments, plants that are not adapted to aquatic environments, and that can actually accelerate that erosion and bayfront loss. So what you often see in response to that is what we would refer to as armoring. And armoring can take a lot of different shapes. It can be, all right, now here I'm going to introduce some more technology that I may or may not be able to use. Let's see. Okay, so you can see my little red dot here, right? So up here in this top left corner, you can see riprap. So this is just large concrete material that is dropped along the shoreline, and it's rough in nature, so it has the effect of, or is supposed to have the effect of breaking up the wave energy and stabilizing the soils underneath. You might see armoring that might even be covered with smaller sediments. One of the more traditional types of approaches are seawalls, or more frequently referred to in this area as bulkheads. And these bulkheads can be made of any number of different types of material, from wood to concrete. Okay. Now, this is all fine and good. And all of these are valid approaches, depending on the type of environment that you're trying to stabilize. In fact, in some cases, this might be the best approach, depending on what the shoreline use is. But it does have its problems. Most often, the problems are manifested in failure of the seawall or riprap or other types of hardened elements. And with bulkheads in particular, bulkheads are a more complicated structure than you might think. And so they have to be maintained. They have to be well designed for the environment in which they're going. Material selection has to be appropriate for whatever type of wave energy that you're facing, the type of soils that are present, that sort of thing. And so this is particularly the case with residential level bulkheads, is that maintenance is often neglected. And in some cases, the design is not appropriate or the materials are not appropriate for the environment they're being placed. And thus they tend to be more prone to failure. And what that failure often looks like is erosion around the side of the bulkhead that then starts to erode behind the bulkhead. If you ever have the opportunity to boat down Dickinson Bayou, I think you can still see this. You can see bulkheads that are separated from the shoreline, sometimes by as many as 20 or 25 feet. Those bulkheads were at one time right against the shoreline, protecting that. They back eroded like you see down here in this corner, and eventually that soil moves out, and then the bulkhead can fail altogether, accelerating erosion further. The other issue with bulkheads and a lot of hardened structures is that they can actually accelerate wave fetch to adjacent properties on either side of the existing bulkhead and across a channel from an existing bulkhead. So you get kind of a multiplier effect that occurs in terms of erosion within a system as a whole. So they're not a fix-all. And so, having seen this particularly in our area, but this is a nationwide issue. It's not just limited to our particular area. But one of the means of trying to solve these problems, stabilizing, eroding, and subsiding shorelines, but doing so in a way that is going to minimize the amount of maintenance that's required, especially for residential level processes, and also provide ancillary benefits, particularly aquatic habitat that you don't get in front of a solid wall, is this approach of living shorelines. Now, again, this is a national level approach. So this is occurring all across the country, particularly on the eastern seaboard, but we see it on the West Coast as well. And here in Galveston, here along the Texas coast, it has been, this approach has been taken up and promoted into not only at the residential level, but oftentimes along very long areas of shoreline by nonprofits, by estuary programs, even by industries in some instances, because you can see this as kind of a hybrid approach, right? So you can see here there's some planted material, there's a breakwater here, there's some riprap rubble, and here's a different version of that same thing. And the idea here is that you're still stabilizing the shoreline. You're providing these ancillary benefits that you might not get with only a hardened, armored shoreline. But the shoreline is self-healing because of the nature of the plants and the fact that the plants alter the sediments in a way that they become stickier. And all of those individual little stems have the effect of breaking up that wave fetch so that it becomes less and less powerful as it moves inland. That's why wetlands are so valuable in terms of reducing storm surge during hurricanes. So we're kind of taking those natural processes and supplementing them with some hardened elements that in turn help stabilize that shoreline, or at least that's the theory behind it. Now, in terms of the types of approaches, they're numerous. A living shoreline is really a custom approach to, depending on what the circumstances are. So if you don't have a lot of wave fetch, if you don't have a significant amount of ground subsidence, you might be able to get away with simply doing some earthwork, some grading to provide the slope that wetland plants need, assuming that everybody is familiar with that. That might be enough to stabilize that shoreline. In other cases, you might have the other extreme where you have very significant erosion, in which case you might need what we refer to as a high profile breakwater with marsh planting behind it. you can almost imagine a window box with plants in it, right? And so, and you might have anything in between. Now, as they get more complex, the project cost, of course, goes up. But again, factoring in the longevity of the projects, whatever your need is, combined with that cost is oftentimes where people will land. So, as I mentioned, this is a nationwide effort and statewide. Again, agencies like the Texas General Land Office have been instrumental in that. The estuary programs like our own Galveston Bay Estuary Program, nonprofit organizations like the Galveston Bay Foundation. And right here in Galveston Bay, GBF has been really the preeminent I don't know, agency is the right word, but organization rather, that is working with individual landowners in order to place these living shorelines. To date, they have placed more than 30 of these. 15 are with private landowners where they have formed private landowner partnerships. Now, I want to take just a second to talk about that, because of all of the states, again, I mentioned this is, very prevalent up and down the East Coast. Some of my consulting work has involved living shorelines in areas responding to Hurricane Sandy, for instance, up in the New Jersey area. And the nature of Texas is very different from many other states, because so much of our land in Texas is held privately as opposed to publicly. And that's not true in places. My wife and I were just, who's on this call actually, we were just in Arkansas not too long ago, and much of the land in Arkansas is publicly held. In Texas, we do have a lot of public land, but most of our land is privately held, and most of the shorelines are privately held. And in many instances, they are held by individuals who may only own small parcels. So if you have a mile of shoreline, that might be broken up into parcels that are owned by 5 or 6 different individual landowners. And that makes stabilizing and restoring a shoreline in a way that's going to be sustainable over a period of 50 years or so is far more difficult. So if you think about infrastructure level projects, when I've worked on levees, for instance, we're working in 50 to 75 year timeframes, because when you make an investment of that caliber, you want to be sure it's going to be there for a while. Well, when you have these little tiny parcels, these little slices along the shoreline, it's not just about what you do on your parcel, it's what's happening on the neighboring parcels, and you have to plan for that, either by working with landowners, and GBF has been able to engineer some projects where several landowners worked with each other and all did their living shorelines collaboratively, so they got the benefit of a long shoreline, or by planning your particular shoreline in a way that it's going to be able to withstand even if your neighbors don't take the same course of action. Okay. So I want to talk just a little bit about our project. The ostensibly, as I said, these shorelines are designed to predominantly stabilize the shoreline so it's not eroding. Most of the time when somebody is doing work along a shoreline, it's because they're losing their private land. This is, again, especially the case in Texas. So when they're losing that land, their first thought is, okay, how do I fix this? And because of the issues that we talked about with hardened shorelines, there's been a lot of outreach to try and soften these shorelines and still provide that level of erosion protection, along with all these ancillary benefits. But there's not been a lot of follow-up study to determine, are these projects actually successful? Are they doing what we anticipate that they're doing, right? We can go and we can say, okay, we worked on this shoreline, we planted these plants, we go back out there a year later, there are still plants there, it must be working. But the fact of the matter is, without a dedicated study, you don't know how the plants are faring. So are they going to sustain over a 25 to 50 year time frame? What is happening in terms of aquatic habitat and those types of things? So the purpose of this study was to go and look at those kind of things. And so we're asking the question, do these living shoreline sites perform functionally at the same level as natural shorelines at the physical and biologic levels? And we're hypothesizing that they would in fact perform at the same level as natural shorelines and better than traditionally armored shorelines along those same parameters. So to launch this, then we worked closely with the Galveston Bay Foundation. I used to work for the Bay Foundation. In fact, I used to manage their Living Shoreline program. So a couple of the projects we're talking about are sites that I either initiated or oversaw the construction on and design. So we wanted to work with them because they've done so many of these. And so we partnered with GBF and we partnered with the University of Houston Clear Lake. These partnerships oftentimes are really important. I get a lot of benefit out of working with partners on this scale of study because that collaborative aspect where you have a lot of different people who have different levels of expertise in different areas, we can do very comprehensive work that way rather than just one of us working on our own. We have been very fortunate to have gotten a lot of this work funded. So I actually started doing the kind of independently working with a few of my students. We started doing some scoping work about in 2013 while Cindy and I were actually working on a large scale restoration study down in Galveston County. But we started doing some preliminary work and then did a full scale pilot, which one of my students is on this call, Emily Blumentritt, and she was on that study and helped pilot that work in 2018. We were funded in 2020 by the Coastal Management Program. We're very grateful for that. That's the data that we're going to be talking about today. And then over the next 2 years, we're going to be doing additional work funded through the Galveston Bay Estuary Program. And we're very grateful for that funding because it helps us do a much deeper level of study than we might otherwise do. Deeper because we're talking about the water. That was hilarious. So, all right. So our sites are located across 3 different areas of Galveston Bay. So Galveston Bay, again, is very large. And the conditions, the physical conditions can really vary from the Gulf-facing area of Galveston Bay down by Bolivar and Galveston Island, as opposed to when you get up near the river mouths, Trinity River, San Jacinto River, even in the Clear Lake area. There is, if you're familiar with estuaries and what they are, there's salinity gradients. There are differences in the types of organisms that occupy these areas because of those salinity gradients, sediment regimes, types of soils that are present, nutrients, all of that, okay? So we wanted to get a cross-section of that because there are living shorelines in all of those. And this approach is being applied in tributaries. It's being applied in the open bay. It's been applied even on the Gulf-facing part of the Gulf Coast. So our study is looking at, again, kind of a comprehensive range of things. So we're looking on the biologic side at the plant community, at the nekton or fish community. We're looking at the organisms that live in the sediments. This includes benthic macroinvertebrates. So these are things like the little worms and clams, amphipods that live in the sediments. And then also we're looking at the microbiologic community, the microbiome, which is an area of interest because microbes, bacteria, fungi, those types of organisms are really important in terms of nutrient cycling, among other things. So, but we also need to look at some physical factors. So in our area, when you look at Galveston Bay, it is largely been affected by humans for nearly 150 years, dating back to well, if you include native communities, even further, but really impacted by urban and industrial development, shipping, that sort of stuff over the last 100 to 150 years. So there's a legacy of contaminants in the form of heavy metals, in the form of organic pollutants, including organic pesticides. There's a lot of agriculture on the Chambers County side in particular, down in Galveston County as well. And those things can impact these living organisms, which in turn can impact shoreline stability. So we wanted to take a look at this. So we examined heavy metals and sediment pesticides, which can impact some of these smaller organisms. And then we also wanted to look at shoreline stability. So that's what I'm going to share with you today. Our study sites, as I said, are spread across the bay. So starting up here in Trinity Bay, this is a very freshwater environment. There is a lot of erosional force because of the flow out of the Trinity River along the face of the bay in this area. If you've ever been up there, spent any time up there, you know that shoreline has been retreating for decades, in many areas at several feet per year. So we were fortunate to work with a private landowner who has held that land. His family, that land has been in his family for generations. They worked on a living shoreline. The site, actually, they've done several of them. The one we're looking at is the one they built in 2011, one that I started. We are looking at a site in Armand Bayou. And in Armand Bayou, that site was also constructed in 2011. And I think Diane Humes is on the call, and she was instrumental in getting this off the ground. And I got to start this project. I did not get the opportunity to see it through. And then also we have a site down in West Galveston Bay in Eckert Bayou. If you know Alison O'Donnell, she, along with many of her neighbors, have constructed a living shoreline along Eckert Bayou, and her particular project was completed in 2005, so it's a little older than these. One element of this I want to point out, and I'm sorry this may be a little small, but if you can bear with me. So each of our sites, we chose these sites not only because they were GBF sites and we had good history on the construction methods when they were constructed and that sort of thing, but we were also able to identify reference marshes or sites that were in the immediate water body near or adjacent to our study sites. So that means we had a natural marsh that was at least 20 to 25 years old, that would have achieved its peak functional biologic function, and gave us a good positive control, a control that would tell us, okay, what are these natural shorelines in this particular water body performing like? And we also wanted to be able to compare against a armored shoreline, again, in that same water body. And by doing it within the same area, it eliminates a lot of the complications that you might otherwise get in terms of comparing data. So, you know, they're going to see the same types of salinity. They're going to see if there's a storm at one of the sites, there's probably a storm at all of the sites, right? And that might not be the case if we're comparing, you know, a site in Trinity Bay to a site in West Galveston Bay. So you'll notice here that these sites, we tried to keep them within a mile to a mile and a half of each other from one end to the other in order, again, to minimize those potential issues. Okay, so this might be a good time for a quick pause and to see if anybody might have any questions at this stage before we delve into what our findings have been.
Yes, Jim, we do have a couple of questions. First question is from our chapter president, Pam House. Would you like to unmute?
Hi, Jim. I was just wondering, I live in an area where Clear Lake Shore, so 3/4 of the island is surrounded by dockage. Is there a reasonable way to combine living shoreline with the need for docks?
Oh, yes, you can. So earlier I mentioned, you know, the type of shoreline stabilization approach you might take would vary depending on what those needs were. Now, in industrialized areas, so if you look at areas in the Houston or Galveston ports where they need immediate shoreline access along large portions with boats that have relatively deep drafts. In those instances, you know, armoring with a concrete or steel reinforced bulkhead oftentimes is really the only manageable thing that allows them to do what they need to do on the adjacent land. But in areas, particularly residential areas, so I'm very familiar with Clear Lake shores, and that area where you have boat docks, actually one of our study sites has a boat dock on it. They're down in Eckert Bayou. Many of those living shorelines have docks that are used regularly. And we're able to work those living shorelines in and around those docks pretty easily. Again, depending on, it really comes back to the wave fetch in the area where you have boats. Sometimes you have to include a stronger structural element. That might include a breakwater, and I think I have some photos of some of the breakwaters that we had placed down there in Eckerd Bayou as we go through this presentation. Does that answer your question?
Yes, thank you very much.
Yeah.
And the next question is from Gib. Gib, do you want to unmute and ask your question?
Yes. Why don't you just let nature take its course?
Well, that's a good question. And actually, that's what's happened at many of these sites for many years. And I want to speak to the human impact here, the anthropogenic impact, which in much of Galveston Bay in particular, but along the entire Texas Gulf Coast, has been very significant to the effect of changing erosional patterns with water, in terms of changing where sediments deposit. The very nature of the Houston Ship Channel, for instance, has changed water regimes and sediment regimes in and along the west bank of Galveston Bay fairly substantively from where they would have been in the 1800s, for instance. Even as, we saw some fairly significant changes even within the last 15 to 20 years as a result of maintenance that occurs in that area. When you start adding structures along shorelines, the fact that we have ground subsidence, which is it's anthropogenically induced. When we pull groundwater out, I'll tell you a short story. So as a good example of this, many of our subdivisions that are outside or were outside of the city limits, the Houston city limits 50 years ago, for instance, would have had a difficult time and did have a difficult time getting water and sewage facilities tied to the city of Houston's facilities. So many of these outlying areas, and I'll use Sagemont as an example since I used to live in Sagemont, that they would drill their own wells, and they would have their own packaged sewage treatment plants. They had piping standards that were to their own standards and that sort of thing. And so because of the nature of our soils in this area being sedimentary, there's not structure to them. So their elevation is in part determined by the hydraulic pressure of the water between each of those particles. So when we sink wells in there and we start pumping that water out, we are releasing that hydraulic pressure, which then allows those individual little particles of sediment to pack together. It's kind of like if you imagine, sticking a water balloon in a sandbox and covering it with sand. It's all fine until somebody pokes a hole in the water balloon and sucks the water out, and then the sand sinks. And that's an anthropogenic or human-induced issue. So we could allow nature simply to respond to that, but what we're seeing is the response is significant erosion of shorelines where we also have human uses, but we also have natural habitats that provide substantively, not only just in terms of their recreational value, but in terms of real economic value. When you look at the economic value of I'll stick with fishing, for instance. So when you combine commercial and recreational fishing, Galveston Bay produces most of that economic revenue in Texas. It is noteworthy in terms of the national amount that it provides, in not only in terms of biomass, but in terms of the amount of funding that it generates. And here in Houston, when people think of Houston, so if I say, what do you think of when you think of Houston? People, my students, a lot of times they tell me, well, we're an oil city, or we're the Bayou City, or we're Space City, or all of that. We should be Fish City, because we're talking about incomes on an annual basis when you factor in not only the catch values for commercial catch, but when you factor in licenses, gear, boats, travel, hotel, tax, associated with recreational fishing, we're talking about hundreds of millions of dollars just in Harris County. So those impacts are really significant. And because they're all tied together, pelagic species, these are species that spend part of their time in the Gulf of Mexico and part in Galveston Bay. They're coming into Galveston Bay in order to reproduce. So they're coming up to lay eggs. And this includes things like redfish, flounder, blue crab, white and brown shrimp, among many others. And so they're coming in because of the wetlands in order to reproduce, and then they're moving back out into the bay, and they're doing it at different times of year. They're partitioning the habitat so they're not in direct competition with one another. So you need this provision to be stable and provide not only for the function of nature itself, but because of the values we get from the economic values. So I don't know, does that answer your question?
Well, that's a lot of words, but really it seems that a lot of work is being done just to accommodate people and people who live along the shores and everything else, where people are building where they shouldn't be in the first place.
Sure.
So
Yeah,
thank you. Thank
could
you.
definitely. I'm sorry, go ahead.
No, that's all I've got to say. It's you're looking at it from a economic situation rather than a natural situation.
Well, I'm using that as one example. If you were to look at it from natural values, again, you could look at the value of these habitats to wildlife. You can look at them from the value of these habitats to water quality. Again, it's not just one thing. We're all tied together. So whether you're focusing on the human element, we're part of nature, or whether you're focused on the wildlife or the aquatic habitat or whatever it happens to be, when you're talking about the water cycle even. All of those things, we're all really part of one big system. So I don't mean to reduce it just to one element, rather it's all important. Could you say that we're building in places we shouldn't? Yeah, I mean, and I think that shows when you have things like storms, like the one we had yesterday. If you built your house in the floodway or within the 1 or 5 year floodplain, you're probably paying for that today. So you can look at it from a number of different perspectives, but yes, you are correct in the sense that we probably shouldn't be building in a lot of the areas we are.
Thank you.
Okay, that's all the questions for now.
Okay. All right. Well, let's talk a little bit about some of the findings. So these are images of students. So, really briefly, one of the neat things about these types of projects is the opportunity for students to collaborate across institutions. So we have Lee College students that are collaborating with University of Houston students. They are oftentimes working with professionals. I've had students that have worked with fisheries biologists to learn how to identify different species of fish. We have worked with professionals in the field to learn about different sampling techniques. They're working with different faculty with different levels of expertise, and that might be folks, students doing benthic macroinvertebrate work, which Cindy is an expert in. Fisheries work that might include sediment contaminants. We have an organic chemist. We have Cindy does heavy metals work. We have a microbiologist here at Lee that's been working with many of the students, plant work and the like. And so it's a real opportunity in terms of students not only to learn about the issues, but to develop skills which will help them then go on into fields where they can continue to give back to the community and solve a lot of these issues that are self-inflicted in many instances, but things that are important to resolve. So let's talk about some of the significant findings. So I'm not going to share every single thing we've done, but I want to share a few of these things. So one of the interesting things we had developed, or one of the things we looked at were plant communities. And so one thing we look at is species importance. And that talks about, so this is Essentially, this is an index that we are calculating for other metrics. So we count the number of stems of each different species of plant that's in a 1 meter plot like this. We measure the amount of aerial coverage, among other things. And so we can take all this and we can factor in and determine, okay, what plants have the most importance within this community based on the samples we took. And so what you're looking at here is a graphic that includes two different sets of data. One, the most recent set we collected in 2021, and then another set that was part of that pilot that Emily and her colleagues collected in 2018. And we've got that for Armand Bayou, denoted by AB here, Trinity Bay, and West Galveston Bay. And we have, because we only had plants at the reference and living shoreline sites, not at the bulkheaded sites, you're only going to see those two areas represented here. And a couple of interesting stories started to come out of this data set. So one of the interesting things has to do with the difference in the nature of the reference sites to the living shoreline sites. And it really comes back to the way marshes evolve over time. So different habitats, they develop from their start, whether that's, from a mild disturbance like a hurricane, hard to believe that's considered a mild disturbance, but it is, to a very severe disturbance. So think about something like a volcano eruption, right? And that can affect how long it takes that community to develop back to what we would consider a ecologically complete, fully functional community. We call that a peak ecologic community. And so our reference site here, one of the things I want you to note is that as you look at 2018, where my little laser pointer is, and you compare that to 2021, you'll note that these different colors, which represent different species of plants. So for instance, blue is a plant that until recently was known as Spartina alterniflora. It's now been renamed Sporobolus alterniflorus, but it's commonly known as Gulf cordgrass. And it is a facultative plant. It will grow in fresh and saltwater environments. And you can see that the importance of that plant to that community has remained very stable. There's been some other minor shifts. So for instance, Scirpus pungens, which is a common 3-square, is a freshwater plant. It has actually increased a little bit over time. And some of these other species as well, those have shifted around a little bit. That's the plant community adjusting to changes in water regime because of rainfall rates from year to year, and potentially some other issues that we'll talk about it as we move forward. But I want you to look at the living shoreline site here. You can see in 2018, there was a lot of that Gulf cordgrass present at our living shoreline site. And when we came back in 2021, within our sample area, there was no Gulf cordgrass. Now, there was Gulf cordgrass in smatterings around the entire site. So when we take a sample, we're only sampling part of it. But what I want you to see here is that there is significant ecologic change at play here. And plant communities do respond relatively quickly to, or can respond relatively quickly to changes in environments. And what we think this represents is what we refer to as ecologic succession. This plant community, which was established in 2011, is still undergoing its successive processes, meaning it's still maturing. And that process in these low marsh environments and estuarine environments like Galveston Bay and our tributaries can take up to about 25 years before it will reach its mature state, right? So we think that's what we're seeing here. We're also, you'll see the same sort of trend here in Trinity Bay, which the living shoreline site is of a similar age. But if you look at West Galveston Bay, where that site is older, so here we're talking about a site that's nearing 20 years, so it's really near its peak functional value, our reference site and our living shoreline site are much more similar in terms of the importance of that Spartina alterniflora and the stability of the site overall. So one of the things that tells us is that when we are constructing living shoreline sites, we need to factor in that the community is going to change over time. So it's not right out of the box, it's ready to go, like you might see with a bulkhead. In this case, there are changes that are going to occur. So when we're working with landowners and actually with habitat managers, that's something that we work with them and explore with them so that they're aware of that and can monitor that process to ensure that that project is going to be successful. And Cindy, please pipe in anytime you would like to add or say anything. Please don't hesitate.
You're doing great.
So here we have more plant data, and so there's some interesting stuff here. So I mentioned we take stem density, and what stem density is stem count. So we count the individual number of stems for each different plant. We look at biomass and chlorophyll. These two values are really important in terms of determining the productivity of the plant. So when you think about what plants are doing, they're producing biomass that is essentially the bottom of the food web for most everything else. But that's not the only thing they do. That's not their only ecologic niche. Plants are really important in terms of nutrient cycling. They are important, in our case, in terms of sediment stabilization. So the number of plants that you have, the amount of biomass, not only at the top that you can see, the shoots and the leaves, but also down here, those root values are really important in terms of how those plants are functioning, especially over time. So you can see, I'm going to take you up here where it says stem density. And you can see here that there is a difference between our reference site at West Galveston Bay down in Eckerd Bayou and our living shoreline site. In fact, in this instance, the stem densities are higher than the reference site. Now, a minute ago, I'm going to go back here, I just showed you, right, this data here where, you know, the importance value is pretty close, right? So that means that in terms of its ecologic function in that community, that Spartina is still really important. But in terms of the density of the plants, we're actually seeing a higher level of density, more plants in our living shoreline site than our West Galveston Bay reference site. And one of the things you're going to see as we talk about this more when we start looking at stability and some of our aerial imagery, that we see inundation occurring in our reference site that is not as prevalent in our living shoreline site. And we think that part of the reason for that is actually the design features that the living shoreline site provides that the natural marsh doesn't possess, and so it isn't as resistant nor resilient to change over time as the living shoreline site appears to be. And we're seeing that in some of these other sites as well, and I'll talk a little bit about that. I also want to draw your attention down here to this graph, and so this is our root and shoot biomass. And so our root biomass, so biomass is the amount of dry material. So we harvest a plant. You can see students over here in this little picture, they're digging it out with a sharpshooter shovel from this little square. It's an 8 meter square quadrat. They dig it out. We take the whole thing, roots and all, back to the lab, wash it all off, separate all the Spartina out. We cut the roots off of the stems, and then we dry them in an oven to get all the water out, and then they're weighed, right? And so roots for actually Spartina, along with a lot of wetland plants, are really interesting. I could spend a whole nother hour just doing that. I'm not going to do that to you. But one of the really valuable things that the roots do is that not only do they act somewhat net-like and can help kind of lock the sediment down, which is there's value to that to keeping the sediments in place, but that actually turns out to be one of the lesser things that they do that stabilize the sediments. The more valuable thing they do is they actually over time contribute organic material to the sediments, and they make the sediments stickier. And so those sediments then become more and more resistant to erosion. And then you factor in the value of the shoots on the top breaking up the wave fetch like we talked about earlier. Well, all right, so I want you to notice something here. So down here on the bottom, again here, I apologize, these numbers are really small, but we've got 2021 and 2018 values for each of our sites in the same order they were before. And I want you to notice that there's a pretty interesting difference here at our living shoreline site between 2018 and 2021, where the root biomass decreased, but it did so also at the reference site. And look at the difference here, right? So some of these numbers are not significant, right? So the measures could be, minor changes in plant density, growth patterns based on rainfall, sunlight, that sort of stuff, even slight measurement differences between technicians between years. These are not significant differences, statistically speaking. This is a significant difference. And it's not so much, we don't see as much change at our living shoreline site. Again, we think this is inundation. It might be related to relative sea level rise. Galveston Island, the backside of Galveston Island, is still actively subsiding to a small extent. But we also have water level as a result of climate change occurring. So we call that relative sea level rise, when the ground sinks and the water's rising. And so we're seeing inundation occur, and you can actually physically see it when you're out there. And that's affecting the stem density of the plants, and turns out the root function. And when you lose the roots, you lose the function of that stability, meaning that that will in turn allow that site to start eroding at a more quick rate. Okay, so in addition to plants, another significant area we looked at were benthic macroinvertebrates. And so these are little crustaceans, little worms and things. Like this is Streblospio benedicti. That is one of our native species here. And so we wanted to look, benthos are really interesting. Benthic macroinvertebrates are really interesting because unlike fish, they don't move around. Fish are they're really hard to sample and get really meaningful data from because they're so transient. Benthos, they tend to stay in one area. They don't travel a whole lot. There are a few species that migrate a little bit that tend to be more predatory, but many are tube dwellers, and they're going to stay in the same area for a long period of time. So the communities give you a good snapshot of what's occurring over a long period of time. And I'm going to point out that I learned all of this particular thing. Cindy taught me how to do all of this nearly 20 years ago. And it's really become a centerpiece to a lot of the work that I do because of the value of this data. So the interesting thing we're seeing here, I want to talk about a pattern here. So when we look at the total number of different taxa, right? So biologists like we're stamp collectors sort of, so we like to divide things up into categories. And so taxa, genus, species, taxa is a kind of a group of those. And so you'll notice in every case, we had more different types of benthic macroinvertebrates, meaning more species performing more ecologic functions at our natural reference site than our living shoreline site, and at our living shoreline site than the bulkheaded site, right? So in this case, when we think back on our hypothesis, our living shoreline sites are not yet quite functioning at the same level for Armand Bayou and Trinity Bay, which are our younger sites, as our reference sites, because there's still ecologic succession occurring. Look at our older site. Here you see it's much closer because this site is much more, it's had longer to continue to develop. And we might be seeing some impacts from that inundation that we talked about. So as we're losing plants, that also over time will impact these other species of organisms that are important to things like nutrient cycling, their food sources for many larger species, and that sort of thing. But it becomes really clear when you look down here and you look at the total number of individuals or total abundance. You can see here, this breaks out, again, big differences between our reference site and our living shoreline site compared to our bulkheaded sites in every case here. So the plants are really valuable to the benthos. The benthos are really important in terms of the functions they provide, which support things like everything from food for organisms to nutrient cycling, right? So this is pretty interesting. Now, I mentioned earlier that we looked at things that might impact these animals in particular. So things like heavy metals and organic pollutants. And I am very happy to report that in all instances across all of our sites, across Galveston Bay, all of the metals and organic pesticides that we examined, which was pretty extensive, all of them were below our screening levels. And so we use a screening level called the effects range low. And This is the kind of the break point where you see no effects from a contaminant to where you start to see some effects. And so they were all below that level, with the exception of the living shoreline site in Armand Bayou, where we had a very, very small amount of copper above that ERL. And copper is toxic to invertebrates, but the level was only 0.02 parts per million above the ERL. So it really wasn't, we don't think that would have any effect of any value. So, and I'm sorry, I misspoke. It was 0.8 parts per million, so even less than what I stated. So to give you an idea of what we're talking about here, when you think about things like DDT, which is a legacy pollutant, it doesn't take a whole lot to have an effect. 0.14 part per million can have an effect on things like brown shrimp, and we've seen that in laboratory environments. So when we're talking about things that are below the ERL, these are, again, things that are not going to have that impact. But what our data here do suggest is that at our two younger sites, we do still have ongoing successional processes developing, not so much here at our West Galveston Bay site that is old. We looked at microbiology. The thing that really came out of this was really interesting in that kind of twofold. Number one, the species that were present were very consistent across all of the sites, whether they were salt or fresh water. The same taxa were present. And so that is not too terribly surprising. But what was really interesting was the function of some of these species. And it's one of the things we're going to be investigating a little more deeply in our phase 2 of this project. But one of the things we found was that the nitrifying bacteria, so these are bacteria that are important in terms of the cycling of nitrogen. Nitrogen is not only is it really important as a nutrient for plants, and it's natural in the environment, it is also one of the things that we as humans contribute most to our waterways as waste. So these bacteria are really important in terms of processing those things. And so the interesting thing here was that the nitrifying bacteria, of course, were more prevalent in areas where we had plants than where we didn't have plants. And in Armand Bayou in particular, so that's this site over here to the left that my little laser's circling. You can see here's our reference site, here's our living shoreline site, here is our bulkheaded site. You can see that there is a clear difference between the reference site and the living shoreline site, and again, a clear difference, statistically significant, between the living shoreline site and our bulkheaded site. And so here again, this points to successional processes. Now, it gets a little muddier. Ha ha ha. Ha ha ha. Anyway, these are the kind of jokes my students have to hear. Ask Emily. So here it's not quite as clear, because we have some impacts occurring at these areas that we talked about inundation, of course, at the reference site here in West Galveston Bay. We also have significant erosion occurring at our sites in Trinity Bay, and that is impacting our reference site probably the most clearly in Trinity Bay in terms of habitat value. And I showed you some pictures of the bulkhead, one of which was from Trinity Bay. So let me show you what that looks like here. So one of the things we did is we flew drones and took low altitude, high resolution aerial imagery that we then processed through a GIS, a global information system, in order to look at stability. Remember, one of the things we're looking at is physical stability. Look at that over time. So here's Armand Bayou, and this is our reference site in Armand Bayou, right? And so this is our, this is what we're comparing against in terms of what a natural marsh should look like. And even here, we are seeing some impacts over time. So if you go from left to right, we're going from 2016, aerial imagery from 2016. This is satellite imagery. 2018, satellite imagery. 2022, and this is generated from our 2021 drone imagery. And you can see across that time that the land cover types are changing, and the amount of coverage is being reduced over time. So where we had marsh that extended fairly far away from the upland shoreline in 2016. So I was out there in 2013 and 2015 with students doing some initial site work. And we took some measurements out there. And I can tell you that there was marsh that extended quite a ways out there. This is right off of Bay Area Park, by the way. 2018, you could see those losses. So now at this point, there was a lot of mud flat during low tides, but the amount of plants had really reduced. And now we're seeing some loss of mud flat. But in this area, this back part of the marsh has remained relatively stable throughout. So when I was showing you some changes in stem densities in Arm and Bayou and root densities in Arm and Bayou earlier, that's what we think is going on here, is there is still a little bit of erosion, potentially some subsidence there that's occurring. So these are the types of physical things that impact these natural environments. At Trinity Bay, so this is a different way to look at this type of image. So here in one image, you're seeing the change that occurred from 2016. So this is our reference marsh at Trinity Bay. This is what it looked like, how far the plants went out in 2016. This is where they were in 2018. And you can see the scale here. So in some areas, the retreat was as much as 20 meters. Okay, so about the equivalent of 20 yards. That is really a lot of erosion. I'm questioning by the time we get to the end of this study, is our reference site even still going to be there? But I want to take the opportunity here, because we flew all of our sites, including our armored sites and our living shoreline sites. This is the living shoreline site at that same Trinity Bay area. And at Trinity Bay, our living shoreline, our reference, and our armored site were all immediately adjacent to one another. So that was a really neat site to be able to work, because you could see things with your eyes without having to travel anywhere. And you can see during that same time frame how stable that living shoreline is, right? So this is all or predominantly low marsh. I won't say it's all low marsh. There is some high marsh back here in the back. But this has been extremely stable. And in fact, it's actually expanded out into the breakwater. So this construction was what we refer to as a high profile. I showed you that earlier, a high profile breakwater with a marsh planted behind it. And it has been extremely stable. And the breakwater itself is actually then providing some aquatic habitat as well. And plants are actually expanding out onto it a little bit. So we see this as very successful, and we're seeing this across all of our sites. So back down to West Galveston Bay, where we're seeing inundation occurring at our reference site, our living shoreline site, the nature of the construction along that shoreline, not only is there a breakwater that is protecting against wave fetch even as the water level rises, but the slope of the shoreline is allowing, much like here at Bay Area Park, it's allowing that marsh to persist by retreating up slope slightly. So in some ways, it appears that our living shorelines may actually be superior to our reference sites, our natural sites, given the stressors that are present, meaning that these habitats would persist longer than they might if we let nature take its course, so to speak. Here again is, this is the bulkhead there at Trinity Bay. And actually, so our reference site and our living shoreline site are right back here in this area. So they're all immediately adjacent. This site was impacted by Hurricane Harvey, outflow from Hurricane Harvey. And at the time, it just created a little nick in the bulkhead. It was a vinyl sheet pile bulkhead. But once that nick occurred, it allowed back erosion to occur, and the whole thing has just collapsed along a huge area. So our sample area was down here towards or up here towards the northern part of the bulkhead, but the entire southern half of it has collapsed at this point. All right, so what's our takeaway from this? What are our conclusions? Well, our results suggest that these living shorelines can be successful in terms of promoting the establishment of aquatic habitat that is replicative of natural habitat within the same system. So within Arm and Bayou, we can create and protect habitat that is similar to what a natural marsh is supposed to look like in that habitat. Same at Trinity Bay, same down in Galveston Bay, across all of those different natural regimes. In cases where there's more severe erosion of shoreline, it appears that the living shoreline applications, because of the hybrid nature of those, where we're incorporating some hardened elements, but softening them with those biologic features, that they may in fact be superior because they're providing opportunities for these marshes to persist in the face of erosion or relative sea level rise, in part tied to climate change or other factors, where the natural marshes are struggling. And in either case, we definitely need to be aware that this is not an overnight process. When you build these, it does take some time for them to reach their peak ecologic function, which does mean that it can take time for them to achieve their peak shoreline stability function as well. So all of those things are tied together. So this is data that should be useful to restoration managers, habitat managers. We've gotten a lot of interest in the research, both locally and at a national level. And so we're really happy with that. We're looking forward to continuing. Oops, I skipped a slide here. Let me go back. We are, as I said, we're moving into phase 2. We are going to be looking at some different things. Microplastics, you probably heard that term, is an area of contaminant research that is emerging, and we are interested in how these sites might sequester these types of plastics, and if that might be having an impact on any of these biologic communities. So we'll be working on that as we go into our next sampling season, which is this upcoming summer. And I want to acknowledge the research team. As I said, it takes a lot of people to put a project like this together and implement it. And so a lot of students, a lot of faculty that have contributed and are continuing to contribute to this. So I want to say thank you very much to each of them. And it takes a lot of cooperation from the community. So not only our funders, but collaborators like Houston Advanced Research Center, Moody Gardens, the Fish and Wildlife Service, among others, our landowners, and of course our funders who make this possible for us. So we're really grateful for that. And if you're just, if you are laying awake later tonight worried about shoreline erosion, I would encourage you to come back to this presentation and just focus on this one slide. It will put you to sleep immediately. And with that, I will conclude. Thank you very much for your patience. I realize I ran over a little bit. That's my way. But I am certainly open to answer any questions if you have any.
Yes, we do. Derek, would you please unmute and ask your question?
Yeah, Jim. So I was curious, what was the more likely factor that drove that significantly notable change in plant community? Was it, I mean, I understand it's a succession process, but was it mainly attributed to the microbiome change, accretion, or erosion of sediment, or have you really sussed out what is the major driving factor?
To really get to that, to really be able to make that determination, we would have to go back in there and we would have to look at the nature of the sediment. So, come to me words. So if you look at the different aspects of the sediment, so the sand, silt, and clay, we call that texture, sediment texture. That changes in that over time can tell you a lot about what's happening in the marsh, nutrient levels. These are things that we didn't measure in this particular go around. We may measure in the future. So I can't say we've sussed out entirely. I can tell you that part of it does relate to changes in salinity. So when you look over time, and a lot of this data is publicly available. So there's a lot of good salinity data out there that is well verified. It follows good QA/QC processes that's generated by Houston Galveston Area Council, the Flood Control District, USGS, and others. And when you look at those trends over time, we have had lower salinities in general across most of the year, excluding 2011 and this past summer where we had severe drought that will allow salt water to push up into our bayous and up into the upper part of the bay. Otherwise, we've had far wetter years, and that has the plants certainly respond to that. I think that's part of what's been going on, and this is a little bit of speculation on my part, but when you look at those salinity values, that would suggest that a truly freshwater plant like 3-square, that Scirpus pungens, is going to have an advantage over a facultative plant like Spartina alterniflora, which grows in a much wider variety of conditions. And so we also saw that. I didn't present fish data here tonight, but when you look at the data that we have, we see that a lot of the species that we're finding are more freshwater. So an example of that are sunfish like bluegill. We're finding in our Trinity Bay site that really shouldn't be out there most of the year. But we're finding them because when you look in the watershed as a whole, flooding and heavy rainfall events as far away as Dallas-Fort Worth can have an impact on us here in Galveston Bay. So I can't tell you entirely what's going on, but we think that's a good part of it. Same down in West Galveston, where we think that there's inundation that's occurring. I couldn't tell you exactly what it is yet.
Okay, thank you.
Yeah. Other questions?
We have another question from Margaret Pierce. Margaret, do you want to unmute and ask your question?
Sure. My question is whether the Jim Blackburn, et cetera, Living Shoreline project, will they use the same shore stabilization methods as have been used in this study?
I can't speak to that directly. I am actually on the technical committee for I guess you're talking about the Blue Carbon Initiative, or are you talking about the coastal spine?
The coastal spine.
Coastal spine. So with the coastal spine, I'm not working on that project. So I did one of my projects with the Corps of Engineers was on the bookends to that project up in, well, actually down in Freeport and then up again in the Beaumont area. But here in the Galveston Bay area, I don't know exactly what they're going to be doing, so I can't tell you that. But I could tell you that the range of possibilities there is relatively narrow because of the amount of erosion and the change in the salinity regime in the Gulf of Mexico. And I won't go into a lot of detail, but a lot of the sediments that we get along the Texas coast are generated from the Mississippi River and a lot of the bayous and tributaries along the upper Texas coast. But a lot of that has changed because of, again, anthropogenic impacts that, everything from the jetties, for instance, are a good example of that in Galveston Island. When the jetties were built, that changed the deposition of sand along the island. And so we're seeing accretion in areas that historically, at least in recorded history, didn't accrete sediment or sand, and in areas that had historically accreted are no longer doing so. So there, because of the amount of change that's occurring there, probably they're going to be higher profile type of structures backed with marsh. So probably more similar to what we have up in Trinity Bay.
Jim, can I add to that?
Sure.
For a second.
Yeah.
There are some projects like down on around Hants Bio, Sportsman's Road area that are much larger projects than the ones that we've been investigating. And I think, Margaret, your question was, are they using the same techniques? I think they're sort of, but just at a much larger scale. They're using a lot of oyster reefing but the ideas behind what they're doing are similar to ours. They want to preserve the marsh. And one of the things that we saw with the reference site for West Galveston Bay is that there have been changes to that site that I think are related to that big, it's not really living shoreline, it's more like a breakwater, but it's the function, the purpose of it is sort of has the same goal as what we have. But yeah, they're causing a lot of changes too. So a lot of work needs to be done on actually studying what's going on when we make these changes to the shoreline.
And it
That's all.
comes back to everything being a system because, everything is interconnected. When you make a change in one area, it might affect 3 or 4 other things, as Cindy's pointing out.
The small ones don't do that as much, but the big ones do.
Sure.
Okay, that's it for the questions. TJ, back to you.
Thank you very much. Well, Jim, Cindy, once again, you have proven my hypothesis. It's good professors and good information given away to the Texas Master Naturalist. And I express my thanks to both of you for your time and effort.